All right, so today we're covering the Bohr model, and our essential question is, how does the Bohr model help to develop understanding of elements at an atomic scale? So this Danish physicist named Niels Bohr developed a model to represent electrons around an element. He knows that electrons act as both a wave and a particle, similar to light, and he proposed that the existence of energy levels around an atom existed. So the energy level is referring to distinct energies that correspond to orbits or circular paths of electrons around the atomic nucleus. And it's determined now that it's more spherical, but we represent them in two dimensions as circles. So the explanation of why the discontinuous atomic spectra was, according to his model, electrons are restricted to specific orbits around the nucleus in a solar system-like manner, meaning that an electron couldn't jump from one orbit to another without some sort of energy. And it's important to think about, quantum mechanics, because these are very small particles. And when you consider really small particles, you have to think about different laws of physics that apply. So there are some assumptions. Bohr suggested that the atoms were restricted to specific orbits, that electrons have constant energy, they can only exist in specific orbits, and he successfully explained the four color lines in hydrogen's atomic spectra, but fails for elements with more than one electron. We know that he developed a lot of important science when it comes to understanding the electron, but this wasn't true for anything beyond hydrogen, and it's no longer accepted as a valid model, but it's used to understand different orbitals and the valence electron shell. Lewis dot diagrams are also used when understanding elements. It's a simple diagram showing the valence electrons around the symbol of the element. It's usually drawn in the shape of a square, and there are never more than 8 valence electrons. They can either be represented by 2 dots around the square, or a line which connects 2 elements, and it represents a shared electron. So, in this compound, water, H2O, oxygen will have 5, 1, 2, 3, 4, 5, 6 electrons around its shell, and hydrogen each has 1. And this is representing the shared electron for those 2 elements. That is the last slide for today, and you'll be having some practice problems associated with this.